Hi everyone, thank you for taking the time to join this session. So my talk is about operating pivotal application service at scale. Most of you guys should be interested in how we are getting along with many clusters. I'm curious about how many of you operate more than 5 PS foundation in production. Can you please raise your hand? Thank you, and more than 10. Ooh. How about more than 20 foundations? Great, thank you. So let me start the session. I'm Yusuke Kondo, manager of the cloud platform department at Yahoo Japan. My team is responsible for operational support, promotion, and management of both PaaS and CaaS platform on which we run our business. And Akinori, who will show the demo on behalf of me.
My name is Akinori Nitta. I work as a software engineer at Yahoo Japan. I am in charge of customer reliability engineer of PaaS team since 2018.
Okay. So last year in SpringOne platform, we had a session about our growing pains during pivotal platform introduction and the outcome benefit of modernization of our development environment. Today, I'd like to share some of our challenges around operating pivotal platform at scale and how we approach them with you. I'm sure you are all familiar with the Yahoo brand. This is top page screenshot of Yahoo Japan website. Let me share a little bit more about our business. Did you know we are the largest internet company in Japan? And we are growing fast. The whole country demands on Yahoo Japan services, so they must never go down. Some of the top page backend microservice is already running on pivotal platform. So let me give you some statistics so that you can understand the scale of our business. More than 1 in 3 people in Japan actively use our services. That's 48 million people. We have a huge user base. And of course, this generates a lot of traffic. On average, we have 93 million unique browsers per day. This comes from a wide range of devices from PC to smartphone to even old-style flip phones. We provide over 100 different types of services to support the Japanese consumer's lifestyle. From shopping to travel to video streaming to auction to finance to news and of course search. These services need to be constantly changed to meet customer demand. So we have an engineering team of over 3,000 people constantly delivering new features. Engineering is our priority for us. So we aim to be one of the best technology companies in the world. Here's our organizational structure. Our PaaS team, which operate pivotal platform, belongs to the cloud platform department. The IaaS team is using both OpenStack and vSphere. The CaaS team is operating our own in-house Kubernetes-based platform. The FaaS team is providing OpenWhisk and Kubernetes-based function services. While cloud platform department is providing 4 kinds of other services, there is also an infrastructure department that is providing department that handles the physical machines. In that department, there's a team builds internal networks, manages appliance products such as load balancers and storages, and operates data centers. So Parts team is composed of two teams, CRE and SRE. CRE has a mission to provide value to developers, while SRE has a mission to improve overall system reliability. Each team works together to maximize the productivity or value of the Pivotal platform. CRE team's mission is to focus on the platform users, the engineer's productivity improvement. There are three main responsibilities here. Firstly, to make the platform easy to use and provide developers with more productivity by developing service broker APIs or some useful tools, libraries, and CLI plugins that helps engineers to ship their apps more frequently. Secondly, to be the contact point of developers to provide feedback and raise issues. The team is also responsible for proactively detecting problems with apps before they become problems and reaching out to developers to improve them. Lastly, the CRE team is responsible for education, providing workshop and documenting best practices, as well as providing architectural guidance. The mission of the SRE team is to maximize system reliability. There are three big responsibilities. Firstly, defining SLOs and setting alerts and monitoring schemes to achieve those targets. SRE team is focused on supporting these stuffs proactively. Secondly, supporting requests from the CRE team. The CRE team gathers feedback from engineers and works closely with the SRE team to deliver improvements. Lastly, the SRE team is also responsible for platform update and enabling new platform features, and also logging metrics for developers. They always try to automate their operation as much as possible to eliminate the tolls. So, as you can see in this table, the number of clusters is increasing every year. There are now currently 16 parts clusters in production. By April next year, we are planning to reach 24 clusters. The size of SRE CRE team has also increased a little. But as you can see, we are reaching the point where the team sizes are not changing substantially. We now have more than 10,000 apps in production, using more than 40,000 AIs, supporting more than 180,000 requests per second. And this graph shows the ratio of build packs used in production. In 2016, when Pivotal Platform was first introduced in Yahoo Japan, most apps were PHP running on OpenStack VMs. At that timing, Java and Node.js were specified as the new standard languages for development. As a result, we required client libraries to support both Java and JavaScript bindings as a priority, and documentation as well. Currently, Java build pack accounts for 45%, Node.js build pack for 30%, and PHP build pack for only 6% of app running on the platform. Therefore, we can say that transition to modern languages and frameworks such as Spring has been going well. From here, I'd like to talk about the main topic, challenges that Yahoo Japan has faced in operating multiple clusters. I will talk about the 6 challenges we faced. For each, I'll first explain the background and then explain how we approach the issue. First is about org space role management across multiple clusters. So the background is, so our developers choose any cluster from our 16 clusters and deploy their apps. So to deploy in multiple clusters, it is obvious that the developer must create the same org and space in each cluster manually, where they push their apps. For developers, it is time-consuming to log into each cluster and managing org space roles and deploy apps. And for PS operator, it's not practical to manage all clusters' org data on behalf of developers. So while most PS admin manage the cluster metadata on the Git repository using the tools such like safe management maintained by Pivotal, our approach is to let developers to manage multiple clusters of org space and roles with self-service tool. The CRE team provides developers with a management console that can manage org space role across all clusters so that those management operations can be done in one place. And this is our management console screenshot. Management console is in-house platform dashboard that can manage not only PaaS, but also other computing platforms such as CARS and FARS, and also identity and access management, key management system, and the API gateway service, etc. So as you can see, list of available clusters is displayed on the top screen of the management console. Each cluster is displayed by data center and usage. The cluster is able to create an org for each cluster. After you created the org in the cluster you've selected, you can drill down into the org detail page. On this page, you can create, rename, delete spaces, and manage the private domain and the org quota. If you click on the space name displayed, you can transition to space detail page. On the space detail page, you can grant a space developer role to a user account and issue an application account for the CD tool. We use screwdriver.cd, the open source continuous delivery pipeline tool maintained by Yahoo engineers, as a CD tool. Since we implemented the function to work with screwdriver.cd, developers can grant a space developer role to CD pipeline so that they can push their apps to the space via screwdriver without using application account ID and password. There's also a direct link to the space page of Apps Manager so that the developer can easily transition to the Apps Manager of each cluster. Okay. So secondly is about automating the routine configuration for multi-foundation. So Yahoo Japan often uses global server load balancing, GSLB for short, to distribute the load between clusters in order to keep web apps stable. With GSLB, the IP address of the target cluster's VIP will serviced out of the DNS entry when the app is down, minimizing the impact of app downtime. However, when setting up GSLB, developers have to open a ticket manually and need to wait until the infrastructure team applies the setting to the GSLB server. Moreover, developers have to manage the app root, which receives the health check request from the GSLB server. To eliminate developers' hassle, CRE Team developed a root service that automates GSLB settings and manages health check root on behalf of developer. We provide this GSLB health check service on the marketplace. Currently, over 2,500 service instances have been created in production. And Akinori will demo how the developer uses this feature.
Okay.
So he's going to type CF Marketplace. So you can see there's a service named YGSLB listed in the marketplace. Okay. So firstly, developer creates a service instance of it, specifying the app root with which should be load balanced by 2 cluster. And he already created a service instance and bound it to the root in other cluster. And he can check the GSLB health check status on the monitoring tool provided by infrastructure team. The tool says the status is up, like the green one, on one cluster. So the DNS lookup of the root would return only one cluster's IP address. Okay. Now he will create a service instance of the same root in another cluster. Okay. So you can see the service instance created successfully. And there's the root map to the app, but no bound service here. Then he does a safe bind root service to the app root. Okay. And let's look at the monitoring tool again. Okay. Okay. So the GSLB status is becoming up to the second clusters. Okay. Okay. And now it will result in returning 2 IP addresses for this app root. Yes. Okay. Thank you, Akinori. And let me talk about the details of the GSLB health check root service. When a developer does a CF create service, a GSLB application ticket is issued. After that, the ticket is processed asynchronously. The settings are reflected in GSLB server, and the periodic health check request comes in. The route is managed so that when a developer does a CF bind root services or unbind root services, an OK can be returned to the health check. In this way, we can easily control GSLB service in and out for the health check route using the service broker mechanism. So load balancing by GSLB become convenient, but there are still challenges for developers to deploy to multiple clusters easily. We had experienced a cluster failure due to the storage error occurred at midnight at the end of 2018, which it took 20 hours to recover. At that time, there was some dying apps that were placed only in one cluster, which was not working. So it was necessary to ask developers to redeploy their apps to other working clusters late at night. Since then, we have been recommended that developers deploy apps across multiple clusters in case of unexpected failures. However, some developers implemented their apps in wrong way. They were designed on the assumption that it works only in specific cluster. So there was a lack of knowledge for designing apps across multiple clusters. Another issue for developers was low motivation to place them in multiple clusters. As for countermeasures to the lack of knowledge, we provided design and implementation examples to increase app availability in multiple clusters. Specifically, we provided a graceful shutdown sample app for the 3 types of workloads, such as web, consumer, and batch apps using Spring. For countermeasures to low motivation for developers to place apps in multiple clusters, we updated Management Console to visualize apps with availability issues across clusters. So it is now possible to view on which cluster the app is deployed via the Management Console screen. For apps with availability issues, red, amber, green indicators are displayed. Red is for apps that only run on one AI. Amber, if the app was only running on one cluster. And green, if the app is running on multiple AIs and multiple clusters. This allows developers to easily check for availability issues and encourage them to keep all their apps green. And the fourth is handling huge log traffics. Last year at SpringOne platform, we talked about using BOSH to automate logging VM management and make the logging relay architecture resistant to failure and highly scalable. The relay server consumes the logs and metrics from Logator and passes it through to the platform-specific agent. There are 2 issues that came out of the operation. One is that it is difficult to isolate the cause of an agent when trouble such as log loss occurs. We needed to understand the logic of each log platform agent, which is now costly to troubleshoot. Second, in order to send log metrics stably, even in the event of failure or sudden increase in flow, it is necessary to operate many VMs for buffering independently. Server management has become easier with BOSH, but as the number of VMs increases, there is a disadvantage that is it takes longer to update. In order to solve this problem, we buffer log metrics in a message queue via producer from a single nozzle. In the nozzle, there is almost no business logic, such as filtering, and the log stream acquired from the log aggregator is passed directly to the producer. In the producer, the message is written to the topic for each message that the log platform wants to consume. The parse team only needs to focus on producer function development and operation. Message queue uses Apache Parser, which is used for enterprise-grade purposes and can handle a large amount of messages stably and scalably. By having the log metrics written by Parser be consumed by the department that manages Splunk and monitoring platform, the parse team does not have to troubleshoot the agent anymore. And recently, as the number of app instances increases, the amount of log messages has increased further. For this reason, we plan to close the default linkage soon. We already launched the log relay service in the marketplace that allows selective log metrics to be sent to any log platform such as Splunk or monitoring platform, or also other logging platform. By dividing the plan for each logging platform, developers can create service instances and send log metrics just by binding to the app. And this is about the automating day one, day two operation. We talked about automation of all operations at SpringOne platform last year. We used concourse for job automation. As a result of creating one job, one pipeline, more than 200 pipelines were created. So there was an issue. A lot of the pipeline were very similar, making management difficult. Every time a new cluster is created, it was necessary to add cluster information to all the pipeline, which was time-consuming. Let's take the smoke test pipeline, which runs the smoke test jobs for each cluster every 5 minutes as an example. If we launch a new cluster in production, we had to add the new job setting to the pipeline YAML and manually fly set pipeline each time. And if the number of clusters reaches 24, the pipeline will be like this. Since there are many jobs besides smoke test, the other 200 pipelines must be updated when a new cluster is released. And it is not difficult to imagine that all the pipeline will like this. We don't want to update hundreds of pipelines. To solve this problem, we reviewed the configuration of one job, one pipeline, and created a template pipeline that bundles all day one, day two jobs required for one cluster. We call it UniPipeline. Setting variables in UniPipeline can automatically generate a pipeline with cluster-specific settings. The part with different settings for each cluster are defined as a variable in the YAML file. And those cluster information can be obtained using the config server API. We use this information to set a different pipeline for each cluster in Concourse. When you want to add a new automated job to the cluster, you only have to edit the unit pipeline instead of creating a new pipeline. When the unit pipeline repository is updated, a self-update will automatically reflect the unit pipeline of all clusters to concourse. So let's take a look at the pipeline. So this is our unit pipeline. And yes, so we made a group for each. So this one is a self-update feature, as I explained. And yeah, so we have many kinds of smoke tests running in each period. And there's also day 2 pipelines. And there's also our add-on applications that will be deployed after launch of the cluster. And that is day 1, day 2 jobs. And also there's a Bosch deployments and the updates. Yep. So it's still in construction, but so we want to migrate our old pipelines to this unit pipeline in near future. Okay. Finally, I will talk about multi-cluster monitoring and getting things done. Although Yahoo Japan is targeted only at the Japan market, we require 24/7 operation. However, our SRE team is not able to work in multiple time zones. As the number of clusters increases, troubleshooting alerts often takes time, making it difficult to allocate time for improvements, such as automation. PCF component metrics obtained with Prometheus are useful for investigation, but there is too much information no navigate to find the cause quickly. If you look at the outliers of PCF component metrics, the investigation will never end. In order to respond with priority, we created our own SLI dashboard with SLOs set to focus on functions from the user's perspective. For example, app availability, management console error rates, and log loss rates introduced in the previous slides. Also, the success rate of blue-green deployment workflows such as push, map route, delete of app is acquired as a SLI. Every morning, we introduce the routine of deciding actions based on the SLO from the user's perspective and adjusting the SLO. So let me summarize the approaches we took to these 6 challenges. For org space and role management, we implemented multi-cluster management tool called Management Console. We only had to make changes in one place. We implemented a GSLB health check root service to also configure load balancing when deploying apps to multiple clusters. We also implemented a dashboard to make it clear to developers when apps may have availability problems across clusters. To handle the ever-increasing log traffic, we introduced Pulsar, highly scalable messaging platform to buffer log data. To manage the explosion of pipeline that we had to maintain, we created a unit pipeline template to auto-generate pipelines for clusters, saving us a lot of time. And finally, we work to focus our SLOs around the developer experience measuring things like CF push, success rate, app availability, etc. Yep, that is the end of this presentation. And thank you so much for coming to hear our story. I hope that some of these things we learn will help you on the journey using the Pivotal platform at scale. If you have any questions, please feel free to ask. Thank you.